Alrighty, time to calculate some volumes. Now what's nice about volumes is you can think of one of those Play-Doh machines. You ever see those Play-Doh machines where they give you like this little piece of strip of plastic and it's got like these different shapes on it, like maybe some kind of star, some kind of circle, some kind of triangle, some kind of whatever. And then you kind of have this, you fill this all up with Play-Doh over here, and then there's this lever that you can push, and when you push, maybe you get like a triangle. It's almost like a spaghetti machine, I guess. You get this my 3D drawing isn't up to snuff right now, but you know what I'm saying. It's a Play-Doh machine. This is called extrusion, actually. Well, extrusion, I guess I think you would pull. This is a push. But anyway, you've got this shape, and because you're mushing some stuff through there somehow, you're getting this, well, we call it a prism, actually. This would be a triangular prism right there. This would be a cylinder, I suppose, if you had a round hole. Whatever the heck shape that is, you'd have a blankety-blank shaped prism thing coming out. Okay, so anyway, if you have a situation like that, or if you can at least imagine a situation like that, like see this shape here, this one here, it's got a triangle. It looks like a, well, short triangle, but we have a triangle end cap, or whatever you want to call it, and then it's got an extrusion length, and I guess I'll just call that capital L or something. This will be called area of, you know what, I'm going to call it area of the base. Think of that as the base. Well, the volume is basically you take the area of the base and you multiply it by the extrusion length. That's all you do. That's all you do. Take the area of the end cap, whatever this face is, take that area and multiply it by this length right here. Now it should be a perpendicular length. You know, you always do it perpendicular. But other than that, that's all you got to do. So then we got an ingot. Here's that ingot. We want to get the volume of that ingot. Well, it looks all nice and perpendicular to me, right? I'm assuming that this was the end area. So we need to find this end area. And then we'll have an extrusion length of 12 inches. So if we find the area of that trapezoid, we can multiply it by 12, and boom, we've got our volume. Watch how cool this is. So the area there is, well, it's in the shape of a trapezoid, so I'll use my trapezoid formula. Remember, the A and the B are basically, that's my A, that's my B, and then the H is supposed to be a straight up height, and this is a straight up height, so the 2 inches is a straight up height. So we've got all the numbers that we need here. So 3 inches plus 5 inches divided by 2 multiplied by 2, you work that out, that actually comes out to 8 square inches, right? Because you're multiplying inches times inches here. 8 square inches is the area of the base. And so the volume then is you take the area of the base, 8 square inches, and you multiply it by this extrusion length, 12 inches. You get 96. And notice the units work out nice because you're multiplying square inches times another inch. That'll give you cubic inches. That really will give you a volume, a suitable unit of volume, 96 cubic inches. So that's the basic idea for volumes, the area of the base times the extrusion length. You can do that for all kinds of shapes. You can do that for this kind of a slanted leaning tower of Pisa circle type shape. So again, this is the, if you think of the Play-Doh machine, it looks like the Play-Doh machine is crooked, but whatever. This is the area of the base, or this is the base. So find the area of the base. It's a circle. So all you guys would do is a pi r squared thing. Or if you have the diameter, you can do pi d squared over 4. So I'm going to do pi d squared over 4. The diameter is 8 centimeters. That's squared divided by 4. And so you end up with the area of the base comes out to 16 pi. I guess I could leave it as 16 pi, but I'm in the mood for a decimal. I don't know about you, but I'm going to go 16 pi button, and have to hit my SD there. 50.265. And those would be square inches because it's an area, right? Now maybe I'll use a different color to do my extrusion. Now the thing is, you need to have a perpendicular extrusion length. L must be perpendicular to the base. And I'm going to scroll up a second here. Yeah, see that perpendicular thing? It's got to be perpendicular. You need to measure that perpendicular. So, guess we'll have to do a teeny tiny bit of trig here, right? So we know that it's 10 centimeters along the diagonal, and we also know that we really want to have this. I guess that's my L right here, right? This is my 10 right here. That's my L. I see a 60-degree angle. We can figure this out. So it looks like that would be a sine, right? Opposite over hypotenuse. So the sine of 60 degrees is the L over 10. And so you very quickly find out that 10 times sine of 60, boom, that L is 8.6603. And those would be inches. Oh, wait a minute, those aren't inches, those are centimeters. Did I mess this up? Those would be centimeters, by the way. Yes. You should have said something. Those are also square centimeters because R is in centimeters. Might as well get it right, right? Right. So we got our perpendicular height, we got our base, and now we can get the volume. Area of the base times the perpendicular height is, we got the 50.265 square centimeter base, multiplying the 8.6603 centimeter straight up height, straight up, not slant height, straight up height. And what's that come out to be? That comes out to be just about 435.31. And these would be cubic centimeters. Is that for any particular unit? Nope, it doesn't. Doesn't ask for any particular unit, so use whatever units you want. Since they gave me centimeters, I might as well say centimeters. P.S. 435.31, you could call those cc's. P.S. 435.31, you could call those milliliters. Centimeter cubes, cc, and milliliters are all exactly, they're just three names for exactly the same volume. Same thing. So you might want to convert that to milliliters if someone's asking you for gallons or whatever, whatever. Okay, so area of the base times the perpendicular extrusion length. Oh, now when it comes to a cone, you couldn't really say that you extruded the cone because, I mean, if you did extrude it, it would come out as a cylinder, right? It's not a cylinder. But that's okay because the area for the cone is actually, or the volume of a cone is actually pretty cool. It's the area of the base times the perpendicular height divided by 3. Ain't that something? You just divide by 3. That freaks me out. So in other words, if you had made a cylinder and then sort of trimmed away all this material out here to get it down to a cone shape, it turns out it's a this is like 1/3, 2/3 ratio here. That's kind of interesting to me. I don't know why these things have to be true, but they are. It's true. So for a cone, and it's the same for a pyramid, right? Cones and pyramids. You take the area of the base, you take the perpendicular height, and you divide it by 3, and that's how you get your volume. Okay, so let's erase some of those circle things. Okay, cool. Let's come down and look at this example. This pyramid shape has a square base measuring 10 foot by 10 foot. The thing is 10 foot tall. Find its volume. Well, that's the area of the base, or that is the base, and the area of the base is, it's a square base measuring 10 by 10, so I guess you go 10 by 10 and you get 100 square feet. That would be the area of the base. Now we need to figure out how much was it extruded. It says it's 10 feet tall. Now when they say how tall it is, they are talking about straight up from the table, so to speak. And that's exactly what we want, so we're just golden, man. We got the 10 feet high. Cool. Again, straight up is what we wanted. So since it's a pyramid, we're going to end up dividing by 3. So it's going to go like this. Area of the base, perpendicular extrusion length divided by 3. So the area of the base is 100 square feet. The length that we, the height, if you want to call it, is another 10 feet divided by 3. It's feet squared times feet, which is feet cubed. You end up with well, that would be like a 333.33, I suppose, cubic feet, because 100 times 10 is 1,000. 1,000 divided by 3 is, 333.33 cubic feet. And they didn't ask for any particular units. So you got to give some kind of units, right? Don't just put a number down. Numbers without units don't tell you how big it is. They just say, oh, that's a nice number. Is that millimeters or miles? Give me a clue here. So do please put your units, whatever they are. And if they're not asking for any particular unit, you can use whatever you want. You want to freak me out? Put cubic furlongs. Go ahead. Anyway, spheres. And I think this is the last page. We always end on spheres, right? Spheres. Well, there's just a special formula you got to know. The volume of a sphere is, turns out it's 4/3 pi r cubed. And I invite you to notice that since you're going to take whatever the radius is, and the radius might be in inches or whatever, since you're going to cubic, you're going to end up with cubic inches. Get it? Times some pure numbers over here. So yes, it is a volume formula. It gives you cubic units. Cubic length or whatever. Cubic feet, cubic inches, cubic centimeters, whatever. Hey, remember this R2D2 shape? We found its surface area before. Now we're going to find its volume. So as often happens with these things, you end up with a shape that's actually built from shapes. So this is built from, we have that would be half of a sphere, sometimes called a hemisphere. And then we have a cylinder part down here. Right, so we have two parts to this thing, a hemisphere and a cylinder. Now for the hemisphere, we're going to use that formula, except that formula is for the whole sphere, and we only got half a sphere. So we'll use that formula, and then we'll have to cut it in half. So the volume would be 4/3 pi. Now we need to put the r in. What's the r? Well, the radius is the same from here to any point on that thing. And you can come down here and say, well, if the cylinder is 2 feet across, and if this is fitting all nice and flush, this must be a r equals 1 foot right here. So the r is just 1 foot. Cute, cool. So put the divide by 2, because that's the volume of a sphere, and then we have a half sphere, so we have to divide by 2. And so what have I got here? I've got 4 times pi times 1 squared. Ooh, cubed. Don't forget your exponent, my goodness. It's not even squared, it's cubed. But anyway, 1 cubed, which is still 1. But anyway, and then divided by 3, and then divided by 2. Come on, you. 4 times shift pi times 1 cubed times, okay, 1. Okay, divided by the 3. Don't forget divided by the 3. But then don't forget to divide by 2, because we only have half a sphere. And in the end, you end up with 2.0944. And I plugged in feet, right? So this would be cubic feet. As for the cylinder, well, a cylinder has a circle base, right? So you would take the area of its base, pi r squared, and you would multiply it by its extrusion length, which is its height, basically. Again, same formula. You can look up pi r squared h on the internet, but notice how you can piece it together. You say, well, the end cap is a circle. I need the area of the end cap, a equals pi r squared. And then how far was it extruded? That's its height, right? So the r is, again, half of this, 1 foot. So pi 1 foot squared, and then the height. Just be a little careful when you go to get the height. 5 feet is not the height of the cylinder. 5 feet is the height of R2D2. R2D2 has kind of a weird head here, right? So we need this, give me a pen. We need this distance here. That's the height we need for our cylinder. So again, if that's 1 foot, then that's 1 foot. So this must be 4 feet, right? Because it's 5 feet all the way up, and then you come back 1, so that must leave 4 feet. So I'll stick my 4 feet in here. And what do I got here? Pi times 1 squared times 4, which is, of course, 4 pi. But as a decimal, that comes out to 12.566. That would also be cubic foot. And so the total volume, well, all you have to do is add those two things. So take your 12.566, add on your 2.0944, and you end up with something like a 14.661. I like 5 sig figs pretty much. 14.661, and these would be cubic feet. Hey, I got it. Oh, I erased my cube. Don't want to do that. 14.661 cubic feet. Hey, I got a special exercise for you. Convert to gallons. Now, I'll give you a little bit of a hint so you don't have to go scrambling looking these things up. 1 gallon equals 231 cubic inches. So if you can get your cubic feet into cubic inches, you can then get your cubic inches into gallons. Okay, why don't you pause, try it, and come back and see what I did. Here's what I did. I took 14.661 cubic feet, put it over 1, and then I say, okay, well, 1 foot is the same as 12 inches. Now this is cubic feet that I want here, not just feet. So I need to make this cubic feet so I can cube the top and bottom of this thing, and it's still an equal. This fraction still comes out to simplifies to 1, but now the cubic feet can cancel. That's good. The point is this 12 has to be cubed. It's not enough to multiply by 12 inches in a foot. It's 12 inches in a foot, but I got foot cubed, so it's times 12 and then times 12 again and then times 12 again. Okay, so that would get me to cubic inches. Right, now I need gallons, so 1 gallon is 231 cubic inches. So that would be your procedure there. So take my 14.661, multiply by 12 cubed, which is 1728, by the way, and then divide by the 231, and it turns out we're talking, wow, we're talking 109.67 gallons. It's over 100 gallons. Well, I guess it would have to be. And I'm just picturing, remember those, those like Chippewa or Culligan 5-gallon jugs? They're not this big, right? They're not 5 feet tall, and they have 5 gallons in them. So we got a lot of those here. So I guess 109 gallons. I guess that's basically believable. I've always been impressed at how quickly volumes turn out. Linear dimensions turn into a lot of gallons. In other words. So cool. So this is good. We're practicing with our unit conversions a little bit. We're seeing some volume formulas for a sphere. Just keep that one handy. That one. And then keep this idea. Well, this is the main idea at the top, right? This works for pretty much any shape. We even derived the volume of a cylinder just using this idea. Take the area of the base times the height, the perpendicular extrusion length, so to speak. Perpendicular, that's what we had to do here. We had to do perpendicular, and then I wanted to say here, when you have a cone or a pyramid of some sort, you use the base again, you use the height again, but it turns out you just divide by 3 and you end up with the perfectly correct answer. It's cool. Okay.